Hello, everyone. My name is Noriaki Tatsumi, and I work for Capital One. In this session, I'll talk about Capital One's approach to running microservices using Spring Cloud, which seems to be a very popular topic this year at this conference. So you might be thinking, what's a bank doing here? It's because our products are technology, and we're really a leading information-based technology company. We're about reimagining the way people interact with their money, and we can't do that just by being a traditional bank. So as we have been, we continue to innovate by embracing open source projects like Spring. So at Capital One, I get to work on an amazing data lake we have in the data intelligence department. Our data lake not only enhances our customer experience across our products, but it also defends our customers and the company from advanced cyber attacks and unexpected outages. I wish I could share the numbers about the magnitude of our data lake, but I'm not supposed to, so let's just say it's really big and it's really fast. So to deliver relevant application and features on a timely manner, we practice continuous delivery as a requirement and not just nice to have or luxury. So we practice these principles, which probably are similar to what you already do. It includes automation, having built-in non-functional qualities, versioning everything, small deployments, and everyone having ownership of their work. But these principles are really hard to practice when you're a large organization. With complex systems, many teams, demanded non-functional qualities and compliances, we have challenges from implementation sensitivity, test feedback speed, collaboration, to security and data lineage across all the applications we have. And the process is to make sure these well-managed, well-managed with every release slows us down. So who shares these challenges with me? I'm glad I'm not the only one here. And our customer expectation is to provide quality, availability, and velocity, but they don't know what technical challenges we have, and they don't even care. So with the guidance from microservices architecture and the 12-factor methodology, we landed on an architecture like this. This is essentially the 5,000-foot view of what our platform looks like. And we have foundation components, including the edge gateway, which acts as the well-known entry point to our platform, as well as discovery and admin servers and authorization servers. The functional team builds the microservices in the middle of the diagram we have here. And there's also ops stack to make sure our platform is up and running all the time. So our secret sauce, out of all these technologies we use, which are mostly open source, it's Spring Cloud. How many of you already use Spring Cloud? Oh, cool. Well, so to us, Spring Cloud is the glue that enables us to build and operate microservices quickly and, most importantly, effectively. And we'll dive into the details now. Now, Spring Cloud has a lot of submodules. And obviously, I won't have enough time in this 60 minutes to talk about every single submodule. But today, we'll be looking at mainly the Netflix module, as well as config, security, and sleuth modules. So without even looking at the microservices aspect, Spring Cloud is really appealing because it's built on top of Spring Cloud. And you all know how awesome Spring Boot is. And we're familiar with the productivity that Spring Boot can provide. And what Spring Cloud does is, on top of it, it wraps Netflix's open source libraries such as Zuul, Ribbon, Hystrix, and Eureka. And as many of you are informed, they're battle tested by Netflix in production. And we'll go into details about what Zuul, Ribbon, and Hystrix, and Eureka, these libraries are about and what they do. So decoupling is how we got started with microservices. With components that are built and deployed independently, many teams can work in parallel without stepping on each other's toes. Enables quicker and smaller deployments that won't require the entire system to be updated every time. We can practice domain design and do one scope of things really well, which is very important when you're working with multiple teams. With microservices, you can choose programming language or technology stack that best suits your each component, feature, or team skill set as well. As you can see, Team C here is working with Java, Scala, and JavaScript, while Team B may be incorporating Python programming. And your functions become shareable as service, often with REST API. This eliminates duplicate implementation efforts, even across different languages. And the functions are independently scalable because they're independently deployed. And because of all the above qualities that you get, you have greater resiliency and better availability. And ultimately, it's really awesome for continuous delivery. But how do I orchestrate all these services? This looks really hard, right? And you might not be working for Netflix or Google for that matter. But there's no need to panic. This is where Spring Cloud helps you. So we'll start with service discovery. It has client and server components to it. And the client is your microservice. The server is where your microservice registers and say, hey, I'm here and I'm healthy and I can take your requests. And it uses Netflix's Eureka library. And by having this component, you can program to locate services, load balance, failover, and self-heal automatically. So let me show you just a quick demo of what Eureka looks like. So here I have a Eureka server running on localhost 8761, and I can query all the apps that are registered to Eureka. So here it says there's 5 applications that are registered to Eureka. And here I see one of them is called Gateway Edge. And it has an instance ID. By default, Spring Cloud chooses to generate instance ID with IP address, the application name, as well as the port number to provide a unique identification to the registration server. And it can tell you, hey, I'm running on localhost. Here's my IP address. I'm up. And I'm running on a secure port, which is with SSL on port number 8443. And so since I'm running on a local host, what's missing here is, let's say if you're running on Amazon, Eureka actually has capability to be going to the what's called Amazon Aware mode, and it can provide you information such as what region is the instance running, or what auto-scaling group it's running, and things of that nature. So you can load balance and share load across multiple regions even. So the rest of this, it provides information about, hey, where's my home page? Where is the status page? Where do I go in order to check to see if the instance's health is good? And then here I can append something like admin, which is the application name, and just get the information about the admin applications instead of getting the entire list of all the components that are registered with Eureka. Or you can, I can even drill down and provide an instance, a particular instance of admin application here by providing the application name and the instance ID that you see on the Eureka server. So Spring Cloud also provides UI that is built on top of Eureka, and so as a admin, you can just go here and get this, like instead of this the JSON string right here, you get to see this beautiful UI and see, hey, I have admin application and I have one of them, and the status is up and it's healthy. And here, if you were running on AWS and running in AWS mode, you can see what AMIs I'm running, as well as which availability zones the instances are in, which is really neat. So going back to the slides, this is how you build the Eureka server. It's super easy. Spring Cloud makes it super easy for you. Essentially, you start with a normal Spring Boot application, and then you just apply the annotation, enable Eureka server. And that's really all about it for the coding. And then you augment that with configurations. Here, the instance is the information about the microservice or the particular instance that the Discover service client acts as. So in this case, I'm saying, that this Discover service or Eureka server itself, I'm registering to the Discover service, and it's called Discovery as the application name. And here, by default, this least renewal interval in seconds is set to 30 seconds. Essentially, this means every 30 seconds, this component will send heartbeat to the Eureka server to tell them that, hey, I'm up. And if you don't send any heartbeat for 90 seconds, Eureka essentially removes you or the component from the registry. And then you can here through configuration set up the different the home page that you want to let the consumers know where that is, and health check URL to status page. And here by default or out of the box, you can set up a basic Auth authentication. In this case, I'm just putting it in a clear text, change me. But there's a way to encrypt them as well. And then where it says dashboard, that's the path that I'm providing the UI and serving the UI from. And under client, this is how you let each component know where the Eureka server is. So in this case, let's say this particular service discovery server that you're providing this config is called Peer 1. And then you set the default zone URL to point to Peer 2 so they can talk to each other and replicate the information, and that's how they join each other in a cluster. And then you also want to set this thing called the health check, enable to true. Essentially what this does is it considers the health check that is provided from the Spring Boot actuator status. So without this, what Eureka does is it pings the health URL, and if something comes back, it says, hey, this component is up, instead of actually parsing the Spring Boot, the response. And if the Spring Boot says, hey, I'm up or out of service, it actually considers that health condition in the status check. So yes. Okay, so the question is, does the Eureka dashboard, is that provided and served by just the Eureka server or every single microservices that registers into Eureka service? Is that correct? So the dashboard and this information is only served by the Eureka server, and the client will talk to the Eureka server to get that information, and the Eureka client do cache that information. I believe by default it caches for 30 seconds, and it goes back to the Eureka server to get the more updated information. Yes?
So should we, if we were going to build that, would we deploy just that one specific application with the Eureka server and don't add any logic or anything else in there? And have the clients then go to this application?
Yes, so there's nothing more to it. So the question is there any additional logic you have to actually implement to deploy this Eureka server, correct?
Should I put any more logic into the Spring Boot application?
Oh, so yes. So I'll talk about a little bit more about what does it take for your microservices to be Eureka client. Essentially, what your application or microservice does is it talks to the Discover server or the Eureka server and gets the information about a particular application's location, and it's really up to your microservices to decide which server to talk to and how to fail over.
Basically, I'm saying, should I put more logic in this code or just put Eureka server and deploy that and worry about the clients?
Yes, you can go ahead and deploy it as is in terms of the Eureka server. Yes. So this is how you make yours Spring Boot application discoverable. So what you do on your Spring Boot microservices side, you add this annotation called enable discovery client. And that's it in order for your application to be discovered by Eureka. And on your microservices, going back here, you provide this the section that's called instance, and provide that information in terms of let's say your application is called my application, app name will be my application, and then you provide where your home page is, where your health check should be, and you skip the passport and dashboard part, but you provide the client information as well. So that is the only part that needs to be a well-known address in terms of let's say you're aiming for a auto-scaling environment and you don't want to hard code any sort of URLs and stuff like that. Eureka service will help you do that, but then each client does have to know where the Eureka server is. So that is the only thing that you need to statically specify in your configuration. And in places such as Amazon, you can use Elastic IP or even Elastic network interface or something like that nature in order to provide a static address, and so that when Discover service does go down and then a new EC2 comes back up, you still have a well-known address for all the microservices to go to. Let's see. And then, so this is something to consider to implement on your Spring Boot application as well. This essentially registers a shutdown hook to make sure as soon as your microservices goes down, you let the microservice or Eureka service know, hey, I'm shutting down. So that way, the Eureka server isn't relying on the 30-second timeout to reflect your state. And as soon as your microservices shuts down, Eureka server knows about that. That your application is or instance is no longer there. And this is how you make your application AWS aware. So essentially, here, this example, essentially I provided this profile called AWS. So I can, from the Spring Boot, when I start up Spring Boot, I can say that, hey, activate AWS profile in order to kick off this piece of code. And essentially what it does is it bootstraps this like Eureka instance config bean with Amazon information, but there's really nothing much to it. Like all you have to do is do this, and then the rest of the implementation for being able to be AWS aware is going to be provided for you. Yes. Yes. So this is essentially how you, the runtime, get runtime, add shutdown hook. This is how you register your shutdown hook to your Spring. Every time this, yes, but it only gets called when when the shutdown signal is received by Spring Boot server. I don't really know. I mean, this is some things the Spring Boot just gives you, some convenience method, and this is something that I discovered, and it just works. So what if your application isn't a Spring Boot application, right? We talked about microservices architecture being able to host all kinds of applications and be polyglot, and doesn't have to be Java implementation. So if you're not implementing with Spring Boot, and then if you still have Java application, then you can just use Netflix's Eureka Java client. Or as you saw, Eureka also has just a simple REST API. So all you need to do is code to that. And the REST implementations include not just like, hey, get the instances that the registration is, the register has, but also it has REST operations to actually register your application and take your unregister your applications and things of that nature. And all that is documented on the Netflix's GitHub website. And then there's another approach that you can take to this. It's called Sidecar or application gateway. This also is a polyglot approach. Essentially, you build this application that sits next to your app, and that enables your application to be service discoverable and secure without changing a line of code on your application. And I'll dive into that in more detail later and demo how that works. So service discovery clients, we talked about using the Netflix Eureka Client, but also in the Spring Cloud, it has libraries to call the Fang or Spring REST template in order to talk to Discover service and get the appropriate address and use that information in order to make the request, the REST call. So with the Eureka server, you can also leverage this administration console Spring Boot. And without providing the Spring Boot administration software exactly where all your microservices are. So this Spring Boot admin isn't part of Spring. It's some other third-party contributor built this, and it's hosted under code-centric organization under GitHub, but it's a really, really neat tool. And let me show you how that works. So this is what it looks like. Using Eureka, it talks to the Eureka and figures out where all your applications are, and it lists all your applications on a single dashboard for you. And then it gets information about the version of the artifact, Spring Boot application artifact that you're running. And then you can get things such as getting the log information straight on your web console, so you don't have to SSH into your server in order to get the log information. Or you can hit this detail button to get further information about all the health checks that you have, about all the actuator, the components that you have implemented for your in your actuator health checks. You can look at the heap information, JVM heap information, your uptime and garbage collection information, to Eureka metrics, and a bunch of really useful information in production. And then if you go to this environment tab, you can see that I'm running this profile called dev right now. And then I have these, I'm running it on 8762, but I have the actuator running on a separate port on 8093. And you can see all these system property information and such like that. And on this overridden properties section, you can actually, some of the properties, you can override it straight from this UI, which I don't really recommend doing, but if necessary, you can. And then here, logging. Let's say you're debugging, and then you want to debug a specific package. You can go here, look, filter by package, and enable that package to start logging. Just that package to start logging debug mode or even trace mode, and then swap it back until you resolve the troubleshooting issue, which is really, really nice. And then you can get information from the JMX. Here, let's say, going to the Duo, and then you can hit on the read information here to retrieve the Duo's routes information here. So you can take a look at, you can interact with the JMX, or you can even take thread dumps. So instead of SSH into your server and providing kill-3 command to get your thread dumps, you can just go here and get this really nice parsed thread dump information, which is really useful for performance tuning. Yes? So the question is, does this work when you have multiple applications or multiple instances of application running for one type of application, you mean? So let's say there's admin, but there's 3 instances. Could you see that information? I'm not really familiar with running in Cloud Foundry. I only have experience running in Amazon, so I'm sorry, I can't answer your question. So, and then lastly, this trace tab is essentially it exposes access log. So here I'm looking at the admin server that I've been clicking around. So you can see all the the trace of all the requests I've been sending out and at what time and things of that nature, which is also really nice for traceability. So this is how you deploy Spring Boot admin. Again, it's super duper easy. Essentially, you start out with a normal, just a regular, very simple, basic Spring Boot application and add two annotations this time. One is called enable admin server, which makes this Spring Boot instance a Spring admin server. And the other is enable discovery client, which enables the admin server to talk to the Eureka server to discover all the instances that you're running and registering on the Eureka server. So you don't have to specifically, install a. So instead of the Eureka, the other way is to actually run this agent on each instance of the microservice that you have, but you don't even have to do that when you're running Eureka because it'll just talk to the Eureka and get all the information and list all the microservice in a single dashboard for you. And when you implement this, there's a little bit of, when you do this with Eureka, there's a little bit of tweak that you need to make in order to display the correct health URL and management URL and service URL, but it's really easy, and I'm sure this deck will be shared with all of you later, and you can just copy and paste this. And in case you have component-to-component authentication, you can leverage Netflix dual proxy filters in Spring Boot admin. Dual proxies essentially handles the routing of requests to monitored microservices, and it's also used in our edge services as well. But for now, just for simplicity, all you have to know is that Spring Boot admin uses Netflix Dual in order to route different requests to different microservices in order to get the health information and other monitoring metrics. And then here is an example of the dual proxy filter. Dual proxy filter essentially takes the concept from just a servlet filter. It's very simple. But what you can do is, let's say there is a authentication, if your microservice is protected with some sort of authentication and authorization, and you need to provide that information for the admin server to talk to your microservices to get information, you can do that by enriching the request, by intercepting the request before going to your microservice. So, let's say basic auth, right? You enrich your request header by, authorization, base 64, encoded information, and so that way, admin server doesn't get denied in terms of authentication by your microservice. So here's an example of how to do centralized monitoring. In our case, we use Kafka as the message broker. And here is what we're doing is for each microservices, we inject this a dependency that we built out in a common library. And we collect these metrics from the Spring Boot actuator and collect all the metrics and place it as a JSON format, and then ship it to Kafka so that other operational instances or tools can consume that Kafka topic and, for instance, then send it to Elasticsearch for that information to be searchable by Kibana or something of that nature. So distributed tracing, this is also a very important factor for managing your microservices. So essentially, as you expand your microservices usage, you're going to have microservices talking to multiple microservices, and you want to know eventually when you're troubleshooting which microservice instance talk to which microservice instance, and further upstream. And Spring Cloud provides this really useful tool called Spring Cloud Sleuth, and how you use it is extremely simple. All you do is you put the dependency in your Maven, POM, or your Gradle configuration, and literally that's it. And as soon as you start doing that, it gives you this information such as span, which is like essentially the basic unit of work. Like for an example, sending just a simple REST call is a span. And also trace ID, which is like that's the set of span information. So span only lasts from microservice to microservice, but trace lasts from microservices all the way down to all the microservices it talks to upstream and then back. And you can, in your log, that this information will be presented, and all this information is added in your request header, the HTTP header. So essentially what you could also do is, let's say if you're running Tomcat in your Spring Boot, you can put an access log pattern and say, hey, you know what? In my access pattern, also put the span ID, trace ID, and parent span ID, and it will give you all that information in your access log, and perhaps you send it to Elasticsearch and make it searchable in Kibana, so that you could say, hey, I want to look up a trace for this particular request, and then in the Kibana you can easily identify how the request went from one microservice to the next microservice, and track all your requests in this distributed microsystem architecture that way. Now we have this handle on tracking microservices. Security comes to our mind immediately as Capital One is a bank, right? And we have to implement this across all components in various languages, which is pretty hard, but again, Spring Cloud really helps us here as well. So some of the things that we have to implement, single sign-on, user authorization, like we talked about component-to-component authentication and authorization, so that not anybody could talk to these microservices. Cores, let's say if you have an API server and UI server on a separate server, like how do you resolve the cross-domain AJAX request, right? You could do, you can implement like the cores configuration, but there may be a better way, which I will talk to in a bit. You also want to make sure that all the requests are getting routed appropriately without getting routed to inappropriate places or getting lost. You want to have auditing and logging, insights and inspection, rate limiting to make sure you're not going to get DDoSed, whether accidentally or by intentionally. And you also want to have a well entry point in the platform in order to see like a good view of how your platform is getting accessed from outside. So most of that problem is solved by the edge gateway. So as you can see, this sits in front of all your microservices. So any request that comes into a request has to go through this edge gateway. So in order to implement this edge gateway, it's, again, super simple. And what it does, what Spring Cloud does is it embeds the dual proxy that we talked about earlier. So in order to do this, again, you create a very basic Spring application, Spring Boot application. And then you add an annotation called enable dual proxy. And you provide routing information in your application properties file or your Bootstrap properties file. So here, what I'm doing here is that by default, ignore all services. Any request that comes in, don't serve it. Don't try serving it. And then the second one says, when you get a root path, request to the root context without any actually context, just a slash, then forward it to some other URI, you can do that. So this edge gateway actually talks to the Eureka server that we talked about earlier. So you can do things such as, hey, whenever /app1 gets called, then it is a application service called application1 and route it. And you're not providing any sort of information about where the application1 is. It figures it out because it talks to the Eureka server and it does the routing to load balancing to failover, all that for you. Then here I talk about, I put this strip prefix. This is a configuration example. Essentially, when you say strip prefix to true, what it does is it strips, in this case, /app1, and to the upstream microservice, it doesn't send the prefix of app1. It starts with whatever the following URI. And then the sensitive headers, these are the sensitive headers that Edge Gateway strips out before sending the request to your upstream microservices. By default, it's authorization cookie, set cookie. So let's say you actually want authorization header to be sent to the upstream microservices. You want to override that by saying cookie, set cookie. So authorization, the request header actually gets passed to the upstream microservice. And if for some reason you're not using Eureka server, or your application isn't registered in your Eureka server, then you could actually say provide a specific URL and the port as well. So in this case, in app2, /app2 should be routed to a different application, but it's an application that's not registered in Eureka. So I specify, to say redirect it to HTTPS app2 on port 8443. So on the Edge Gateway, because it's the entry point to every request, you can do authentication just one time instead of doing it everywhere in your platform, which makes complete sense, right? Like you don't want to be implementing authentication mechanism on every single microservices, nor have the overhead of doing authentication in every single microservices for the end user. In our case, Capital One, we implemented the capability to do both SAML 2.0 to do SSO, or we can also do Auth 2.0. And I'm not gonna go into the details about how to implement SAML and Auth here because that's a little bit out of the scope. But you can see some samples on the GitHub. You can easily find them at these addresses. So we talked about filter earlier when we were talking about providing authentication request enrichment in the admin server. And this is how you implement the filter. So you extend this class called ZooFilter, and you provide this filter type. In this case, the type is, I set it as pre, which means, hey, run this filter before you route the request to the upstream microservices. There's other types, such as post, which is like, hey, intercept and run the filter after you get a response. There's also route, and then there's also error. So, we talked about the enrichment of authorization header, and that's exactly what I'm doing here. And you can use this filter to not only enrich requests, but also inspect the requests or collect some statistics about all the requests that's coming in. Remember, this is the edge gateway, which is the entry point to every request. So it's a perfect place to collect all the information, statistics about all the requests that's coming in. And then going back to the concept of sidecar or app gateway, like I said earlier, it's a application or a process that you run next to your own microservices. And essentially what it does is, even though your microservices might not be fit to do discover service and things of that nature, it enables you to do that. And this is how it works. So your application is running on the bottom of the diagram here. And what it's doing is it's running inside the server that's also running a sidecar. And then what you do is you bind your application to localhost. So requests coming from outside world cannot talk to it. But then what you do is you bind Sidecar to your server host name and IP address, and enable your Sidecar to talk to your application. So all your requests has to go through the Sidecar. So what that does is it gives you the opportunity to do logging or some sort of inspection if it needs to be, or do additional authorization or something of that matter. And if your application isn't a REST service or any sort of web application, then you don't have to run the proxy aspect of Sidecar. You essentially just run it without it, but it still does the discovery for you. And in that case, the discover service isn't very useful, but at least it could do things such as monitor and then do the health check against your application, even if it's not a web service, and then talk to discovery and say, hey, this process is still up and it's in good, healthy condition. So I want to do a quick demo here. So as you can see on this Spring Boot admin UI, there's the admin server, there's the edge gateway we talked about, but I also added this things called Gateway Elastic and CATEWAY-KIBANA. So these are the sidecar, or what I'm also calling application gateway. So this is running on the same instance, but running in front of it. And it also looks for the health as well. So let's say if I kill Kibana, it might take a little bit of a while to notify us, but essentially I have this background task that is continuously monitoring the Kibana URI and URL, and after some number of attempts, if it doesn't come back with a healthy response, then it lets the Eureka server know that it is down, and eventually lets the Spring Boot admin know that it's down as well. So I can't remember exactly. I should know this, but I can't remember how many attempts it takes. But here you can see it did a heartbeat attempt, and it failed twice so far. I believe I set it to after third time, go ahead and let the admin server know that it's down. We'll see about that, and then we'll come back to it. So Spring Cloud actually has the concept of Sidecar, and they let you implement a Sidecar just by adding an annotation called enable Sidecar as well. And in your code, in addition to putting this annotation, you have to put your server location and what your Spring application name is, and what URI it should use to do the health check. So this is, out-of-the-box capability is really nice, but we take a little bit different approach. We still just use the regular enabled Zool proxy, but we implement our own health check just because this out-of-the-box health check capability is not sufficient for us. In this case, it always tries to expect just a regular 200 from health.json, which might not be sufficient in your case. So what we do is we create a health indicator, additional actuator health indicator, and we have that monitored and have we have this convenience method called app heartbeat check is healthy, and this is a method that's running a Spring scheduler and then continuously checking for the health, looking at, in this case, localhost 5601 and expecting response code 200 in this case, but you can do a lot more advanced stuff. Let me see if this has been updated. Yep. So as you can see, it finally, I don't know exactly when this got updated, but now the Gateway-KIBANA is out of service. So now Edge Gateway or any of your microservice clients that talks to Eureka wouldn't get this instance of Gateway-KIBANA as a healthy instance. So you wouldn't send any requests to it. So circuit breaker. Circuit breaker is a microservices a pattern. Essentially helps to reduce resources. Well, essentially so in microservices, there's a lot of connections or communication that goes on between the microservices. And let's say one of your microservices goes down, and another microservice is trying to talk to it, and let's say if it waits for a connection timeout, that's a lot of time wasted. So in order to avoid that, there's this pattern called circuit breaker, and essentially you provide a rule to say, hey, you know what, when this method fails X number of times, then default to using another method. Let's say that method might be, a static, response instead of going to another microservice, or essentially a failover method that it provides. So it's not going to go to a microservice that the instance is expecting to fail, because that's just waste of time. And this is a code sample. This is how you implement it. In your Spring Boot application, you add annotation enable circuit breaker. And in the the method that you want to apply the circuit breaker, you annotate with hystrix command. So hystrix is another library that Netflix provides, and it does circuit breaking. So you can see that we are applying get stores this hystrix annotation, and with the after a certain number of failures, it goes to default stores. So Zuo is a very useful and awesome component, but there's a couple of gotchas that we saw was a little bit insufficient to implement all the requirements that we have. First is that it doesn't have sticky session, and in microservices and total factor app, like your application is supposed to be stateless and it shouldn't matter, but we have legacy applications and third-party applications that actually need sticky session. So in that case, you can't have it go through Zuo. So that's a little bit of a challenge, but there is a way to implement a rule in the ribbon library that Zuo embeds in the Zuo embeds, and you could write your own sticky session implementation if required. Second thing is that WebSockets, server-sent events, and HTTP2 aren't supported yet. So if you want to do some fancy, more of a push type of communication between your UI, that's not really supported either. So those things are things to consider before leveraging Zuo by replacing something like Nginx. And I want to talk about versioning. I think versioning is a super important microservices architecture, and because there's so many components, you might end up with so many components in your platform, and it's really important to make sure that, let's say you're using REST API, that the REST API definition or signature that a client is expecting is what it is. So at Capital One, we use what's called semantic versioning, and it has 3 components to it. There's major, minor, and patch. The major, the first number that's there indicates the API compatibilities. So let's say it's 1 and you incremented it 2, so that indicates that the previous API signature is no longer compatible. So essentially, it it helps you well manage your microservices architecture by making sure that the API signatures conform, and then they're aware of each other in terms of what version you're running. And then for the configurations as well, I think it's very important to version everything, including your configuration. You don't want to change something in your production and not track it, or or other people to not be aware of it. So with configuration, we put our configuration in Git, and then we use the Git revision hash in order to version it. And all configurations, after checking in, are applied with automation, so that nobody is just going into the platform and changing things, and the rest of the people aren't aware of it. And so, speaking of configuration, as you might expect, you actually end up with more configuration to manage than your a typical monolith application, because there's so many integrations between across your microservices, and it just creates more configuration because there's more processes and servers to manage. So you wanna make sure that your configuration is well managed, and Spring Boot application already does that for you. As you guys know, it's really good with providing out-of-the-box capability to manage all the configurations through properties, and even provide you with capability to manage different profiles, so that based on the different environment your application gets deployed, you can just specify, hey, I want to run like a production profile, I want to run a QA profile to take different configuration into effect during your deployment. And Spring Cloud also has this submodule called Spring Cloud config. And essentially what it does is it bootstraps the Spring application configuration or your main application, and it gets loaded before your regular Spring Boot application properties. And the purpose of this bootstrapping is it enables you to manage your configuration externally, such as from this like Spring Cloud config server. So essentially, you can push different configuration through this config server, and it manages the configuration through, let's say, like the Spring config server can be backed by like a Git repo. And Spring Cloud config also out of box gives you encryption and decryption capability to your sensitive properties, so that's really useful as well. So at Capital One though, or at least in our department, we don't use Spring Cloud config server just because we believe in minimalistic deployment. Essentially what we do is just commit the configuration changes in the Git, and we just have, we already use Docker and Ansible to do the deployment, so we just rely on those two automation to do it. And that way we have an immutable infrastructure instead of something that config server manages. So other key things, DevOps culture. You want to make sure that you're talking to your ops team. Auto scaling and like implementation resiliency doesn't happen like on your own or without talking to the ops team. Yes. 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 EC2, yes. Yeah, we're looking into ECS, but currently what it does is we have CloudFormation that bootstraps with the Docker daemon, and we just call Docker compose to compose all the containers and then deploy multiple containers in like a single server, and that's how we manage Docker containers. I'm sorry, can you? So the question is, the different EC2s, are they? Yes, they are. Are they dynamically provisioned? Yes. And then we can do that because there's the Eureka server. We can take down, as long as your application is stateless, you can take down your application anytime and spin up a new one, and Eureka would find out your new instance without letting your load balancer configuration know that, hey, here's a new instance. Not right now. Purely done by Zuo itself, yes. So the question was, if we're using both Zuo and some other reverse proxy engine such as Nginx, and the answer is only dual. And then also, I really think good documentation to all your projects is a key for multiple teams to be using that information or your projects, so that your components are shared across multiple services and other teams aren't rebuilding what you already built. And then lastly, automate everything. And I don't really need to say anything more about that. So this is my last slide. Essentially, the takeaway is that it's not hard to get started with microservices architecture if you use Spring Cloud in our experience. And I really advocate that you guys also do it and start delivering faster and deploy more frequently. That's all. Thank you very much.